Good evening, dear students. Today we will be we'll be continuing from what we have discussed in the previous class about global warming and how renewable energy addresses the technologies of renewable energy addresses energy requirement, plus also um, mitigates global warming causing effects and addresses the SDG, the Sustainable Development Goals. One of the basics of global warming, key factors of global warming is greenhouse effects and the carbon cycle, which we discussed in the last class. But I'll start a little bit from a recap from the last class so that we can understand better what we are trying to when we move on to the next class. Just a bit of a rerun of what is greenhouse gas and how greenhouse gas affects and what is the carbon cycle. Now we all know about the climate change. Human activities, particularly the combustion of fossil fuel, যে আমরা তেল থেকে বা কার্বন বেসড ফিউল থেকে কম্বাসন করে ফসিল ফিউল থেকে আমরা এনার্জি উৎপাদন করি. That's one of the key contributors towards global greenhouse warming, greenhouse gases going up, and also global warming. I made a blanket of greenhouse gases. Say, if we were to think about um, when the earth itself has evolved, and along with that industrialization and civilization, all of it has gone on to a exponential growth in the last century, if not in the last half of the century, where digitalization and radical development of technologies have opened up the world to a whole new era. Now, with this comes hand in hand a lot of requirement for energy, and our energy demand has to be met by either there is renewable energy, which is also a very new concept and address the technology only recently have become matured enough to be able to address maybe 10% of the world's energy requirement. But mostly, predominantly, the most largest source of energy has been fossil fuel, coal, oil, and other, or even wood, trees, um, biofuel. This kind of sources which has to be combusted, which has to be burned, has been the main source. Also, there has been another source is nuclear, but not a lot of the country has a lot of the countries in the world have developed nuclear technology because it still uh, is fairly expensive technology, and not everybody has the technological know-how, and also the geographical location might be a key factor as well. Say, for example, in places like Bhutan or Nepal, in these areas, having a nuclear power plant is strategically very questionable. So, moving on, when we burn the fossil fuel, we all know it gives out carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen oxide, and other harmful carcinogenic gases, or what we say all in a combination becomes global greenhouse gases. Um, Now, when the amount of coal combustion or fuel burning increased, with obviously it came hand to hand increase of exhaust fumes or gases, harmful gases up into the air. And what we see now, if you see the London fog or smog, or in China or in India, which are the densely populated developing countries, fast growing countries, you'll see they have a very, very high reading of pollution in the air. And also sometimes it's difficult to breathe or even to see because it gets so uh, gloomy and dark from all the pollution in the air. So when there's a lot of uh, exhaust gases, fumes in the atmosphere, it forms like a blanket in whichever area there is. First of all, it affects the area where it is local area, and then with the carbon cycle or with the airflow or um, the circulation, the carbon then moves off from one place to another place. Now, there's two ways it affects. It affects the locality, it affects globally. But nonetheless, these global greenhouse gases that are emitted in the air stays and has a detrimental long-term effect. So um, gases, some gases break down easily, some gases stay in the atmosphere a lot longer, some gases affects um, just due to the content of the chemical content or the what the elements they have in the gas, they can be harmful in certain ways and some others in a different way. Say for example, methane is a natural gas that comes from animal and even human body producing from the food that we eat. These gases tend to stay in the air a lot longer. It takes a lot longer to break down, whereas carbon monoxide can break down easier. And water vapor, it's one of the easiest to break down. It can, the water from the water vapor, it gets absorbed and causes rusting or oxidation. And also the oxygen and the carbon, hydrogen, it's very easy to separate in the atmosphere by itself. So they tend to stay the least amount of time, whereas methane stays the longest, and ozone, it seems to be the lightest one that goes up and most common effect it causes, it breaks down this atmospheric covering that we have, thus causing a hole in our stratosphere and allowing harmful radioactive radiations from the sun to enter through that particular area. Um, right now, the funny thing is, global warming, in one hand, the greenhouse gases in one hand are forming a thick blanket around the Earth's whole. It's like a blanket around the Earth atmosphere. In the same time, one of the key factors of global warming, which is ozone gas, is also creating holes in the atmosphere. So like I said, it's localized, has a different effect, and it globally, when it moves on and it breaks down in the process, it has a different effect on the atmosphere. The resulting increase in global temperature is altering the complex web of systems that allow life to thrive on Earth, such as rainfall, wind patterns, ocean currents, and distribution of plant and animal species. See, when the environment is changing, when there's the temperature is going up by slightest half a degree or even 1 degree, with that change comes to change of the local species biodiversity, which in turn has an effect on what the humans are doing. So it's a cycle. It's a catch-22 cycle where life depends on development, life depends on energy, and then that energy, how we consume it, becomes a detrimental fact for our life. So life demands energy, and energy demands life. In a way, we can say that. Um, global warming, global temperature alteration, even though it's changing by a slightest 1 or 2 degrees, say for example in the ice shelves, in the polar caps, in the Arctic regions, we all know that global warming by 1 degree or 0.5 degrees is causing huge areas of ice shelves to melt down, thus increasing the level of water in this world and increasing the risk of tsunamis and other natural disasters a lot more frequent than how it used to be before. This slight alterations has a complex has an effect that disturbs or alters the complex system we have that holds the whole Earth's biosystem or ecosystem in place. Um, that throws যখন 1 ডিগ্রি টেম্পারেচার ডিফারেন্স হয় তখন বায়োডাইভার্সিটি ফার্স্ট অফ অল ইকোলজির উপরে একটা এফেক্ট আসে, দেন বায়োডাইভার্সিটির উপরে এফেক্ট আসে, দেন বেসিক্যালি when the biodiversity itself has been affected, it comes down to affect the human species as well. Now, if you see in this diagram how atmosphere and the greenhouse gas, how it works, the greenhouse gases can stay up, go through this layer. The solar radiation passes through the clear atmosphere. Incoming solar radiation at 343 watt per meter square. That's a lot of energy coming per meter square from the sun. Then it hits most of it gets bounced off or reflected away. Some solar radiation is reflected by the atmosphere and at surface. Wait, let me just make this a little bit bigger so it's easier to see. Okay. Okay. Yeah. See, so when the sun is giving energy at 343 watt per meter square, that energy reaches down onto the atmosphere, and then the net incoming solar energy is 350 watt per meter square, from which some gets lost. Initial reflection goes off to outgoing solar radiation is 103 watts per meter square. It's deflected off from the Earth's surface, and some of them, especially some of the infrared radiation, is absorbed and re-emitted by the greenhouse gas molecules. Basically, the greenhouse gas molecules in the atmosphere also can absorb and re-emit, or basically reflect of some of the X-ray, some of the radiations from the sun. The direct effect is the warming of the Earth's surface and the troposphere. So when the radiation comes through and hits the troposphere, a lot of it gets absorbed, um, some of it gets reflected, and then some of it gets through the troposphere and enters our Earth's our lower atmosphere. Some of the infrared radiation passes through the atmosphere and it is lost in space. Um, Most of the infrared radiation going out is approximately about 40 watt per meter square, and solar energy is absorbed by the Earth's surface and warms it up by about 166 watts per meter square. The energy that finally, up after passing through the troposphere, it comes to the Earth's atmosphere, it comes to the Earth's surface, so heating up the water and heating up the land. That energy comes down to 166 watt per meter square. That energy is then the gained. There's a surface gain. The surface gains more heat and infrared radiation is emitted, um, and is covered in converted. The infrared is converted into heat, causing the emission of long wave infrared radiation back to the atmosphere. So there is long wave infrared and there's short wave infrared. The short wave infrared is the one that comes from the sun. The shorter wavelengths can travel for a lot longer distance, and the ones that comes and hits our Earth's atmosphere is the longer wave radiation. Now, life on Earth is made possible by energy from the sun, which we all know, our main source of energy that makes our Earth and our Milky Way, or our planetary system, or our galaxy, um, our um, solar system works, is from the energy is from the sun, um, which arrives mainly in the form of visible light that we can see the light, but inside the light there is also many other wavelengths that we don't see that gives energy as well. About 30% of the sunlight is scattered back into the space by outer atmosphere, so that the sunlight that comes, like I said, from the sun at 343 watts per meter square, about 30% of that it gets reflected back from the atmosphere into the space, or stays gets absorbed in the troposphere, and the balance 70% reaches the Earth's surface, which reflects it in form of infrared radiation. So the heat that we get on our Earth's atmosphere, on our skin, on our body, on the Earth's surface, is the infrared radiation, the long wave infrared radiation that gets through. The 70% of that it comes through onto Earth's surface. The escape of slow-moving infrared radiation, the slow infrared radiation, the smaller one radiations, is delayed by the greenhouse gas. You see, the problem is if the radiation was coming in and then getting reflected back, that would have been fine. There will be a balance between influx and outflux of solar energy. But what happens because of the thickening of the greenhouse belt, if you want to call it, the gas um, layer that makes it difficult. It forms a blanket around the Earth's atmosphere. It doesn't allow as much of the infrared to get reflected back, so it holds it on, thus increasing the temperature inside the blanket, inside the cover. Um, so that's why, because it takes longer to go out into the atmosphere, it stays lingering in our lower atmosphere and thus increasing the global temperature by ever so slightly, by half a degree or even quarter of a degree or even 0.025 of a degree over hundreds of years. A thicker blanket of greenhouse gas traps more infrared radiation when in some places where there is more pollution and the blanket is thicker, the radiation stays in longer and there's more radiation that stays in that area and increases the Earth's temperature. We just saw in the figure. So move on to the next page. Greenhouse gases make up only 1% of the Earth's of the temperature of the percent of the atmosphere, but they act as a blanket around the Earth, or like a glass roof of a greenhouse. Greenhouse, if you guys know what a greenhouse is a house made with glass, which basically lets the radiation come in, holds onto the temperature, and does not allow it to pass out. And that's what our that's what the blanket around our the greenhouse gas blanket around our atmosphere is doing. It's allowing whatever amount of radiation is coming through, it's just trapping it in and making sure it stays inside and increases the Earth's temperature by ever so slightly. uh, Greenhouse and roof of a greenhouse and keep the earth 30 degrees warmer than it would be otherwise. Now, you see, because of the glass roof or the greenhouse gas uh, covering blanket that we have over our around the earth's surface, it is increasing the earth's temperature by 30 degrees than it should have been normally. Now, not to say that this is all very bad, because we do need some sort of temperature on the earth to be able to live comfortably and for our biodiversity to thrive. But 30-degree plus is not very desirable. Without greenhouse gases effect, it would be too cold to live. So, like I said, we need some amount of this greenhouse gas as a blanket to keep some of the energy, keep trap some of the radiation in the Earth's atmosphere, inside the atmosphere, so that the greenhouse gas um, uh, so that the Earth's temperature is not too cold. Because if there was no blanket and all the energy just came and got reflected and bounced off, the Earth will be too cold to live. Human activities that are responsible for making the greenhouse layer thicker are emissions of carbon dioxide from the combustion of coal, oil, and natural gas, by additional methane and nitrous oxide from farming activities and change in land use, by the several man-made gases that have a long life in the atmosphere. See, like I was saying before, because of the combustion of coal, oil, natural gas, these are one of the main contributors that's going into the atmosphere and causing and emitting carbon dioxide, and also methane and nitrous oxide. These are mostly human or agricultural farming waste from livestock or from species, or even the fertilizers processing in the ground. And the gases, these gases tend to stay in the atmosphere a lot longer, and also some of the man-made gases that have a long life in the atmosphere as well. The increase in greenhouse gases is happening at an alarming rate. In greenhouse gases emissions continue, if greenhouse gas emissions continue to grow at a current rate, it is almost certain that the atmospheric level of carbon dioxide will increase twice or thrice from the pre-industrial levels during the 21st century. Like I said, the 21st century and especially the later half of the 21st century has been a phase for transformations, like the industrial revolution or the digital revolution that has come again, uh, which directly is a reason for the global warming gases or greenhouse gases to increase almost 2 to 3 fold, almost by uh, twice double or three times what it used to be before we went into industrialization. But then also with the industrialization, we have the ability to develop our technology, which is then used to come up with solutions, technological solutions, or innovative ways to manufacture harmless energy or green energy, and also to recycle the some of the heat that we are getting naturally to make good use of it instead of using man-made processes to add more pollution and add more temperature to Earth's atmosphere. Even a small increase in the Earth's temperature will be accompanied by changes in the climate, such as cloud cover, precipitation, wind patterns, and duration of season. You see, এখন আমাদের দেশে, especially in Bangladesh, if you can relate to, you see the winters are getting more severe, the duration of the winter has changed, the summer has changed, rainy season stays and lingers around for a lot longer than it used to be, and the summer temperatures have increased to the all-time highest level that we have never experienced before. Also, if you think of the winter season, Bangladesh has seen temperatures that we have never seen before, almost nearing uh, freezing temperatures, almost reaching 5, 6 degrees in some areas of Bangladesh. Now, this didn't used to be the scenario in a few years ago. This is why we say even the slightest change on the Earth's atmosphere everywhere makes a huge change in the local areas. In an already highly crowded and stressed Earth, millions of people depend on weather patterns such as monsoon rains to continue as they have in past. Even minimum changes will be destructive and difficult. See, our countries like in the Delta region, countries who are bounded by water and waterlogged areas, countries, they depend heavily on, also in the tropical region. I would say in the tropical equatorial areas where there's a significant amount of rainfall and it's a seasonal, it's one of the vital parts of the season is the rainy season. Here, you see people depend on the monsoon season for depleting, for filling up the depleting water bodies where they can farm fish, they hold on to the water reservoirs, and also then to circulate it around and for fishing and everything else. So, our Earth is already very crowded and stressed. Millions of people depend on Earth's weather patterns. If the weather is too bad, too dry, too hot, then there's drought. If it's too rainy, there's flood. So this makes us think and gives us a warning that even the slightest bit of change that we don't really care about, the small polythene bag, plastic bag that we just threw away after having our burger, it's we don't really care. But this small changes is affecting everybody around the world in evidently in the long term. So we cannot, there is no short-term solution for this apart from just becoming more and more careful and more environmental friendly and reducing your energy usage, reducing your carbon footprint, and using less and less um, man-made products which are harmful to the environment. Carbon dioxide is responsible for 60% of the enhanced greenhouse effect. There are, like I said, in the greenhouse gas list, there is carbon dioxide, carbon monoxide, sulfur, nitrogen, a few other gases. But carbon dioxide itself is the main contributor. 60% of it is the carbon dioxide. Humans are burning coal, oil, and natural gas at a rate that is much faster than the rate at which these fossil fuels were created. Now you know how fossil fuels are created. It takes hundreds of years of natural process of going through high pressure, temperature, and long, many years, hundreds of years of decaying, decomposing, and compression of organic material uh, produces what we call is um, natural gas or like I said, biofuel or fossil fuel, not biofuel, it's fossil fuel. Fossil basically comes from dead elements, dead plants or animals, which have been fossilized for hundreds of years in the Earth's atmosphere, just kept on, just got oxidized, climatized, and pressurized into converting into fossil fuel. Um, Now, the amount we are burning now in this 21st century, the rate at which we are burning coal, rate at which we are driving so many cars, flying so many planes, the amount of fuel that we are sucking out from the earth and just burning it like that, it took hundreds and hundreds and thousands of years to build or form, and now we're just burning it off in a few years' time. So it just throws the Earth's biodiversity or the Earth's ecological um, time frame totally off balance. So if there was a balance of amount of energy we are using, fossil fuel you're using, that fossil fuel is then uh, we are we are burning it off to plus carbon dioxide in our atmosphere, and it is it takes a lot it takes a lot more energy to capture the carbon dioxide back from the atmosphere and then do the whole process that took thousands of years naturally, and to do it by technology or by humankind, it is a lot slower process. Um, so the burning process is much faster, and the formation of fossil fuel, the creation of fossil fuel is a lot slower. This is releasing the carbon stored in the fuel into the atmosphere and upsetting the carbon cycle. Like I said, faster than the rate at which these fossil fuels are created. This is releasing the carbon stored um, in the fuels into the atmosphere and upsetting the carbon cycle. A precise balanced system by which carbon is exchanged between the air, the ocean, and the land vegetation taking place over millions of years. That's what we call is carbon cycle. Carbon cycle is basically the precise balance. You see how much carbon is made. Carbon is there in trees, carbon is there in the earth, carbon is there in our skin, carbon is there everywhere. All the organic material, all the organic things are carbon based. It's hydrocarbon based. It's hydrogen and carbon. So these hydrocarbons or the carbon based elements, when they are in the Earth's atmosphere, it takes a long time to build up and then very quick to dissipate. And this exchange, um, the system, the of exchange between the air and the ocean and the land and the vegetation taking place over millions of years. The vegetation basically means the trees and plants that have been dead and decaying in the ground, and the air and the land. The land puts the pressure, the ocean and the air oxidizes. All these elements together coming and recycling the carbon from one form to another form is called carbon cycle. Currently, carbon dioxide levels in the atmosphere are rising by over 10% every 20 years. Now, this is something really alarming. If it's increasing, if carbon, wait a second. Okay, if yeah. Currently carbon dioxide levels in the atmosphere are rising by 10% every 20 years. So if you see 10% every 20 years, that will mean by next 100 years, it will be 50%, almost half increase, and that half or 50% of increase in carbon dioxide in the Earth's atmosphere will result in increased temperature, which will make the water level go up, and vegetation, biodiversity, and all of that gets affected inadvertently. Current evidence of climate change is cyclones, storms, hurricanes are occurring more frequently, and the floods and droughts are more intense than before. Like I said, the winters are getting a lot more colder, and summers are getting a lot more hotter. This increase in extreme weather events cannot be explained away as a random events. You see, when we have events like wildfires spreading across America and South American countries, when we see severe storms and cyclones and hurricanes and snow blizzards affecting the Northern American region, when we see these cyclones and thunderstorms or um, this kind of calamities or weather anomalies used to take place a lot more in the eastern region of the earth, but nowadays we see this is happening also in the western areas, western continents as well. So this extreme increase in the weather events are not just a random one-off. You see this is changing and there's a pattern, there's a way it's going up every year. So there's a link directly between the increasing severe weather anomalies and increasing industrialization, in thus increasing carbon dioxide or greenhouse gases in our atmosphere. The trend towards more powerful storms and hotter, longer dry period is predicted by computer models. Warmer temperature mean greater evaporation, and warmer atmosphere is able to hold more moisture, and hence there is more water aloft that can fall as precipitation. Similarly, dry regions are prone to lose uh, still more moisture if the weather is hotter, and hence this leads to more severe droughts and this desertification. This was very simple that we just discussed. I'm sure you understand. Warmer temperature means greater evaporation. গরম temperature থাকলে, if the temperature is higher, there is moisture in the air. That means there'll be evaporation will be more. If there's more evaporation, then there's higher atmospheric moisture. Um, and the warmer temperature, when in the cold temperature, moisture turns gets heavier and then comes down on earth, but in the warmer temperature the moisture tends to float around a lot longer and it tends to be able to hold a lot more moisture than colder air, and hence in the warmer areas it will keep getting warmer and more humid. That will bring around more precipitation. That means more rain will happen in those areas. Similarly, dry regions are prone to lose still more moisture if the weather is hotter, and hence this leads to more severe drought and desertification. So we are also expecting to see in the regions where the temperature is getting higher, there might be in the next 50 years new deserts forming, and the places where the water level is rising, there might be new areas of flooding, where we know that some regions of earth, some countries are already in the eastern in the eastern Pacific, where past Fiji and Hawaii kind of area, there are islands which are now almost under threat of disappearing from existence. Islands which have population, and now they're worried as to relocating themselves somewhere else, as their home, their land, their island is slowly starting to drown away in the ocean. Even the minimum predicted shift in climate for the for the 21st century are likely to be significant and disruptive. Predictions of future climate changes are wide-ranging. The global temperatures may climb from 1.4 to 5.8 degrees Celsius. Now, we all know we are talking about keeping the global warming to 2 degrees below. So we are increasing and temperature is going up by 2 degrees. So if we, the COP27, the most recent energy IPCC conference that we had, committed to keep the global warming below 2 degrees. Now, if that is the case, you can understand how simple 0.1, 0.2, 0.5 degrees, how much difference it makes, where we are saying that the global temperatures may well increase from 1.4 to 5.8 degrees. Now, if there's a 5.8 degrees increase in the global temperature, there is a very good possibility there will be severe weather anomalies that will change the Earth's outlook altogether. The sea level may rise from 9 to 88 centimeter. From 9 centimeter is what we are having difficulty to deal with right now. And if it was rising to 88 centimeter, you can imagine a lot of countries, a lot of cities in this world will just slowly disappear under the water. Thus, increasing in sea level this century are expected to range from significant catastrophic catastrophes. This uncertainty reflects the complexity in interrelatedness and sensitivity of the natural system that makes up the climate. It is important that you know what are the importance and how the global warming is affected by these gases, and slight changes in the temperature like 1.4 degrees to 5.8 degrees can result in water level rising from 9 to 88 centimeters. um, I myself am 163 centimeters, so which is 5 feet 7 or 6. If the water level was to be 3 feet high, higher than what it is now, a lot of these places, a lot of the countries, a lot of the cities would just disappear.